Morning everyone, I'm Panchajanya. I work as a TA in Visual Resources Collection, and from past 2 semesters I have been conducting workshops on digital photography and stop motion animation, and this is my first workshop on camera lenses. It's an advanced level photography workshop. It's good if you have some knowledge of DSLRs and camera equipments, but it's fine if you don't have. Um, so if you have any questions, feel free to ask along the way. Don't keep it till the end because you might not understand a few things. So before I talk about camera lenses in particular, I'd like to tell you a little bit about photography in general. Photography is essentially about capturing light, right? It's all about light. So when we talk about photography, you should, camera in particular, you should know three important things. That is how light enters your camera, how your camera measures it, and how to control the light that is entering the camera in order to capture the pictures you want. And here I have two images. One on the right is a diagram of a simple pinhole camera. As you can see, the light is getting reflected off the tree and it's going inside the pinhole, inside the camera, and it's hitting the backside of the camera, and there'll be some means to capture that image. And at the bottom, I have the evolution of camera technology. So the first one is camera obscura. It's one of the earliest versions of camera, where it used to be a simple box with a simple lens fitted in the front, and there used to be a tracing paper at the back, and a person used to actually manually trace the light rays which is projected on the tracing paper. And then slowly, as technology evolved, the tracing paper got replaced by a metal plate, and then it got replaced by photo paper and films, and SLRs came, and digital point and shoot cameras, and now we have phone cameras. So basic idea of showing these two images is that irrespective of the technology we have, the fundamental principle on which camera works remains the same, that is capturing the light. In the first camera, it was done manually by actually tracing it, but now technology does everything for us. So let me talk a little bit about how single lens reflex, that is SLR cameras, work. Doesn't matter whether digital or film SLR, they work in the same way. This is how a simple cross section of any SLRs look like. There is lens and there is body, and within the camera body there is a mirror at 45-degree angle, and on top of that there is either a pentaprism or pentamirror, some kind of mirror which reflects the light, and at the back there is shutter, and after that there is either a sensor in case of digital SLR or film in case of film SLR. So this is how it is before you click the shutter release button. So light coming from the lens, it gets reflected by this mirror and goes on top, gets reflected multiple times and goes to the eyepiece. So you're actually seeing what's coming directly through the lens. And once you click the shutter release button, this mirror goes up and the shutter opens up, exposing the sensor or film. And then when you leave it, it will go back to its original position. So the time period between opening and closing shutter is nothing but shutter speed. So this is how any SLR works like. And there are mainly two parts in any camera, that is lens and camera body. In case of SLRs, you can see the distinction clearly because you can actually physically separate the lens from body, but in other types of camera you can't see. But there are two different things because they fundamentally do two different things. That is, what lens does is it brings in the light in the way you want it. Like say you are using a wide angle lens, it lets light from a wider angle of vision. If you're using a telephoto lens, it lets in light from a very narrow angle of vision. So let's move to now. In this workshop, we are going to focus only on the lens part, and all you have to know about the body part is that it captures whatever lens is giving it. So now let's know a little more about camera optics. So as you all know, light refracts in different medium, just like the one in that picture in water, and the same principle used in camera optics. Depending on the shape of the lens, light refracts in different ways. Say in convex, light rays converge, and in concave, it diverges. So using this simple principle, a complex set of optics are designed for any particular lens in order to project a bigger frame on a smaller sensor or film, or it could be even smaller than the sensor, depending on the kind of lens you're using. Especially if you're using macro lens, it can be as small as the sensor itself. So as I said, lens projects the image on the frame. When it is projecting the image, it's not projecting a rectangular image, right? Because the lens is circular, so it's going to project a circular image inside the camera, and the rectangular frame is cropped out of it. That's only this much part is stored in the camera. And now it's important to know different formats of camera, because every format and every brand has its own lens system, and some of them are not compatible with each other, but some of them are. It depends on mainly depends on the size of the sensor. The standard size is 35mm film size, or 35mm full frame camera sensor, and as the technology evolved, they realized that you don't need that big of a sensor for normal purpose, so they made the sensor smaller, which is now called crop sensor, and they designed a whole set of lens system for that particular sensor format. Here you can see this is a crop sensor camera, this is a 35mm sensor camera, and this is the subject. The subject height is the same in both the cameras, but you can see the lens in crop sensor has a smaller focal length. Why is the focal length? Focal length is nothing but the distance between the sensor and the point of convergence inside the lens. So in crop sensor it is Y, but in full frame sensor it's going to be more than Y, because the sensor size is bigger. So it becomes confusing if you just say focal length for a particular lens. Say if you say you have a 35mm lens, that doesn't mean anything, because you don't know the format of the lens, which format it is designed for. If you say 35 for a full frame camera, then it means something. So you should always refer to both format of the lens and focal length. So now let's look at depth of field. This is very important in photography. So there are what is depth of field? Depth of field is nothing but a depth in front of lens within which everything is in focus. Say you're focusing this camera. When you capture a picture of this camera, it doesn't mean you're going to capture only tip of this camera, right? The whole camera is going to be in focus. That means it has depth. It's not just a plane which is in focus. So that depth is affected by aperture and focal length. So for a particular focal length and aperture, there is a fixed depth of field. So now let's understand what is focal length. As I mentioned earlier, focal length is the distance between optical center or point of convergence and the sensor. That is focal length. So as I said, focal length is relative to format of the camera, but there is another term which is diagonal angle. That is not relative to any camera format. That's how much area it's going to cover. So if you say that particular camera has 6.2 degrees of cone of vision, then it means it's going to cover area that comes under that cone with that particular angle. So as you can see, this example is specifically for 35 mm sensor camera. As you can see in 14 mm, it's super wide. It's gonna I don't have 14 mm here. It's gonna cover a lot more than a 600 mm lens. See, at 600, it becomes very small. So it depends on what you're shooting. If you're doing architecture photography, you would need a wider angle because you're going to be very close to the subject, and you have to cover a larger perspective. And this is another example. Here, the area covered remains the same in all these images, but the person itself moves in order to capture the same area. So you can see how the perspective changes. At 16 mm, it looks super distorted, but at 200 mm, it's very flat. Normal focal length, which is very close to our human eye, is 50 mm. That's again particular to 35 mm cameras.
So if you're doing portrait photography, so
Sorry,
like
what?
focal length, like portrait photography.
Portrait.
Kind of average distance from a subject if you're taking portrait, for example. So 50 millimeter focal length would be kind of what people normally go for, or
Yeah.
this would usually kind of use.
Yeah, 50 mm would be ideal.
Okay.
But it's sometimes it's not possible because you'll be very close to the subject, very close to the person you're shooting. So 50 mm would be too long. So you might have to use a little smaller focal length, maybe 35. But yeah, you're gonna get some sort of distortion. Ideal would be 50 mm. So next I'm gonna talk about aperture. Aperture is another important thing that's related to camera lens. It's nothing but an opening within the lens between the frontmost element to the lastmost element. I'm going to show you. Actually, see, this is the frontmost element and this is the lastmost element, and in between you can see the aperture opening. Yeah, there's a lever here. You can turn that and it opens up.
Okay.
That is aperture. So what aperture does is it affects the depth of field, of course, and it also affects the amount of light entering the camera. So aperture is a fraction. It's usually indicated as is the denominator of the fraction. That's why it becomes a little confusing. In cameras, you can see only the denominator 2.8. So lesser the number, bigger the aperture. So if you say 2.8, it's a big aperture, and if you say 32, it's a smaller aperture. Bigger the aperture, you're going to let in more light. Your image is going to be brighter. Smaller the aperture, it's going to let in less light. That's how it affects light. And depth of field, smaller the aperture, you're going to have smaller depth of field. Bigger the aperture, you're going to have smaller depth of field. As you can see in that picture, at f1.2, only the tip of the kettle is in focus. but in f16, even the background, the plants are in focus. So we spoke about aperture and focal length. Now I'm going to talk about file format. Usually we use JPEGs, but that's not advisable for professional quality photography. I recommend always use RAW format. RAW format is uncompressed. It's unaltered by camera in any way. It's going to store all the information that it's going to capture. That's why it's going to be raw files are going to be 3 to 4 times heavier than JPEG format. So if you save your images in RAW format, when you drag and drop it in Photoshop or Lightroom, you're going to get this raw editor, which is an inbuilt plugin for Photoshop. If you don't have it, you can download it from Photoshop website. It's for free. And once you drag and drop it, you'll get this raw editor, and you have several options that you can change, like exposure, contrast. You can change the histogram, you can change the perspective. So you can basically do a lot of things that your camera actually does. So here's an example of a raw image edited, and here's an example of the same image in JPEG format edited. You can see how much information is lost in JPEG. Here you can see so much more detail, but here it's all blown out. Now I'm going to talk a little bit about distortions and imperfections caused by optical limitations or sensor limitation. The first one is distortion, perspective distortion. If you might have noticed, if you have used wide angle lens, you get this kind of barrel distortion where the vertical lines are not parallel to the frame. It's gonna be curved, and also sometimes it could be the other way if you are using a telephoto lens. So the best way to avoid this is use mid focal length always. Say for example, if you have 70 to 120 lens, always use not always, like preferably use 70 to 120, like 95 focal length, which is the mid of that focal length.
95 millimeter.
95 millimeter. So I mean, it's not possible to use 95 always, because what's the point of having that range? But preferably use mid focal length, so you can minimize the distortion from the starting itself. And another way of correcting the distortion is using RAW. If you use RAW and if you go to the RAW editor, there is this lens correction part. Once you put the RAW image, it's gonna give Photoshop all the details about the image, about the camera and the lens and the focal length, everything. So if you just click on enable lens profile correction, it's gonna detect all the details, and it's gonna compensate for all the distortions that would have caused by that particular lens for that particular focal length. So all you have to do is just click enable lens profile correction. And I spoke about optical distortions. Now there are other kind of distortions like color fringing and vignetting. Color fringing is nothing but when different wavelengths of light doesn't converge at a point, you can see color fringing like this. So the best way to avoid this is use RAW again and edit it in Photoshop, or you can use lenses with ED lenses, which is extra low dispersion lens elements, or aspherical lens elements. I'm going to talk about that in the end. And the other kind of distortion is vignetting. Vignetting is when the light doesn't enter the corners as much as the edges. Like you can see, as I told, that when the lens is projecting the image, it's going to project a circular image, and the rectangular image is cropped out of it. So as you can see, these corners are almost touching the periphery of the circle, so it's not going to get the same amount of light that this part is getting. So it's going to be darker. So best way to avoid this is just compose your frame in such a way that you can crop it later. That's very straightforward way of avoiding it. And also raw, you can use raw format and you can correct it. And sometimes using smaller aperture will, yeah.
That's a question, since you're the expert in the room. What for a lens hood? I have one, but I'm not necessarily aware of all of the benefits and all of the limitations, or unintended consequences of having a lens hood or using a lens hood while shooting. So
sure.
I was just told that it looks it helps in some way, so it wasn't a very good advice.
Again, first of all, lens hood is very important, especially when you're keeping your lens, keeping your camera like this.
To avoid breaking.
Yeah, because the frontmost lens element is going to be always big and it's going to be very sensitive.
Mm-hmm.
So if you're gonna keep it like this, it might break if you like just throw it sometimes. Mm-hmm. But with lens hood, it'll minimize the damage.
Okay.
So, and another advantage is sometimes you would have seen lens flare. Mm-hmm. If there is harsh sunlight,
right,
you would see those circles. Mm-hmm. If you use a lens hood, that is going to be avoided.
Okay. Gotcha.
These are the two main advantages. There might be other advantages, but I might not know. So that's vignetting. And as I said, using raw, you can correct these distortions. If you go to the lens correction, if you go to manual, you can see lens vignetting. When you hit the automatic correction, it's gonna compensate lens vignetting to an extent. But if you think it's still there, you can use this lens vignetting and correct it. Also in color, in the same tab, if you click on color and remove chromatic aberration, it's gonna remove the chromatic aberration. So now I'm gonna talk a little bit about cheaper alternatives for lenses. Most of the professional grade lenses are always expensive, especially if the focal length is more, and if the aperture is very constant throughout the focal length. Say this is a standard portrait lens in Canon, which is 70-200 with f2.8 constant. It's $2,000. It's expensive, and the same equivalent for that in Nikon is $2,200. But there are third-party lenses, which third-party companies which make lenses for Canon and Nikon, like Tamron, Sigma, Zeiss, brands like that. So they are going to be cheap. Like the equivalent lens would be $1,200. It's almost half the price you would pay for a Nikon lens. But in terms of image quality, it's not much of a difference, right? You can see Canon, Nikon, and Tamron. You can't see much of a difference. I mean, it's again lens specific. Not all third-party lenses are good, but most of the branded lenses are good. So you should do a good amount of research before spending on any third-party lens. And there are other sorts of cheaper alternatives which are not necessarily lens by itself, but addition to your standard lens. So what basically for converting one format to another format, or converting one type of lens, standard lens, to a particular type of lens, or increasing the focal length and things like that. So the first one is conversion across brands and formats. So say if you have Sony camera and your friend is ready to give you a Canon lens, which is a $2,000 lens, you don't have to buy a new camera body for Canon lens. You can buy an adapter and you can fix that lens on your camera. And same way, conversion can be within the brand itself, but with across different formats. Say you have a Canon full frame camera, full frame lens, but you have a Canon mirrorless format camera. So you can buy an adapter which converts the full frame lens to.
Yeah, that's a real huge lens for that camera.
But that
Yeah.
break?
It would break. Like you have to hold the lens, not the camera.
right.
So yeah, so that would save you a lot. Like instead of, if you had to buy a new full frame body itself, it would cost you like $4,000, $3,000, $4,000.
Is there any issue with like image fidelity when you're using those types of adapters?
There is some, but
Maybe a little.
it's very little. It again depends on how much you're ready to compromise. Yeah, but most of the photography, this would be enough. But if you're very particular about the image quality, then you might have to go for a full frame body. And there is Teleconverter, which converts the focal length, which is mainly used for telephoto lenses in wildlife photography. So a photographer might have a 400 mm lens, but if he uses 2x teleconverter, it would convert it into an 800 mm lens. So instead of 800 mm lens in Nikon would cost $12,000. So if you use teleconverter with a $400 mm lens, which is $3,000 or $4,000, you would save like $10,000, $8,000 to $10,000. And there are also wide angle adapters. You have, say you have a 1855 mm standard lens and you want a wider angle, then you fit this wide angle adapter in front of the normal lens and it would increase the angle of view.
Are they usually expensive?
No, then all these adapters are super cheap.
Relatively, yeah, they're all cheaper than buying a lens.
Yeah, exactly. This would be probably around $80, $50 to $80. I don't know the exact cost. But yeah, it's gonna be definitely a lot cheaper than buying a new lens itself. And there are lens reversal adapters, which are for macro photography. Say you have a 1855 mm lens and you want to do macro photography. You just buy that and reverse the lens and attach it to your camera, and it's gonna turn your normal lens into macro lens. It's basically because all macro lenses are designed exactly the opposite of normal focal length lenses. So you just reverse the lens and you can turn your $50 lens into a $800 wide macro lens. And again, there are other types of limitations in this particular lens. In terms of quality, you're not going to compromise on anything because it's the same branded lens. It's just reversed. But you can't set the aperture in this because the aperture ring is on the other side. But you can manually do it. If you're experienced enough, you can change the aperture size by manually holding the lever and using the camera shutter release button. And there are adapters like polarized filters. I mean, these are not necessarily adapters, these are filters. Polarized filters and neutral density filters. These are mainly used for cutting down the light that is entering the camera. Say for example, in most cases, the problem would be not having enough light, but in some cases, it would be the other way around. For example, if you're shooting in bright daylight and you have set the aperture to its maximum and you want to do a longer exposure to say you're shooting a building with people around it, and you want to capture the movement of people. So you would want a longer exposure. So that would let in a lot more light, which you don't want. That time you use either ND filters or polarized filters, which is nothing but a thin dark lens, plain lens fitted in front of your normal lens, which is going to cut the light that is coming inside your lens. So these are the different types of adapters that you can use for your lenses. And this is the last slide, which is gonna tell you the different terms used in there are much more than this, but these are the most used terms in Nikon lens system. So first of all, DX is the camera format. When it says DX, it's a crop sensor. It's not a full frame lens. So if you have a DX camera, make sure you are buying a DX lens. And silent frame motor is a technology used for focusing elements. It's the latest technology in lens focusing system. And VR is vibration reduction. It's good for sports photography and other sorts of photography where the subject is moving. And ED is extra low dispersion. It's gonna minimize the effect of chromatic aberration. Internal focusing system, it's technology used in lenses nowadays, which has lens elements within the camera barrel itself, which moves within the barrel. You would have seen older lenses where the front element, as you focus, it moves. The lens hood moves, rotates, and the lens barrel moves front and back in order to focus. But with internal focusing, it's not going to move, especially if you're doing macro photography. If you're very close to the subject, if the lens moves, then it's going to touch the subject, right? So having IF is really important. And aspherical lens element is just like ED. It's going to cut down chromatic aberration. And this one is lens diameter. This is also important. Sometimes it will be written on the front of the lens itself. It's important because you have to buy filters for your lenses. So you have to buy that particular diameter of filter.
And so with the lens filter diameter, is that symbol, is it kind of like a circle that's kind of crossed out?
Yeah, it's diameter.
So I'm just trying to locate it on a Canon, like
yeah.
For a Canon.
I mean, it might not be the same in Canon. I don't know how it's.
This particular one, it just says that it's on the bottom.
Yeah. Okay. So when you see a number like this, it means diameter of the lens. And there's also a manual and autofocus switch. You can switch from manual focus to autofocus. It's pretty simple. And when the lens says N, it means nano crystal coating. It's a special type of coating which improves the durability of lenses. This is the aperture size. You can see here 1:4 G. That means it's 4 aperture throughout the focal length range. Or if it has a range of aperture, it would say, for example, say here it has aperture from 3.5 to 5.6. So it says 1:3.5 to 5.6.
Okay.
So here it's constant throughout the focal length. So it just says 1:4. And next to that is focal length range. It says 24-120. That's the focal length range. If it's a time lens, then it will have single focal length. It will be fixed. Probably it will be 50 or 70, depending on the lens you have. And AFS lenses are Nikon lenses with built-in motor. that's all these terms are specific to Nikon brand. You will have to look at Canon website for Canon equivalent for these. So AFS lenses are they have built-in motor to focus, so you don't have to have a motor in your body in order to focus. But some of the Nikon high-end professional cameras have built-in motor, so you can use older lenses with only manual focus capabilities, and you can turn that into autofocus lens if you're using a higher-end camera. Example, this one.
May I ask which you prefer, manual or autofocus?
I prefer autofocus most of the time because it's very precise. Because you're gonna be seeing the image through this eyepiece, and you can't really tell if it is in sharp focus or not with that small screen. So it's better to leave it to the camera focus. But sometimes it's hard to focus because the frame will be very tricky, and camera won't understand what's happening, and it won't know where to focus. That time you have to manually focus. And there are also eyepiece enlarger that you can buy which will enlarge the eyepiece.
Make anything.
Yeah, you can. Yeah, I can do that. And yeah, again ED and vibration reduction. So yeah, that's it. Have any questions?